Welcome to Chapter 1, Quadratic Functions. A reminder that to be quadratic, we have to have x to the second power. So our variable's highest exponent would have to be a 2. It has to at least have the x squared. If it only has x, then it is linear. So to be quadratic, you must have x to the second power, something like y equals 2x squared plus 3x plus 1. In this first section, we will take a look at quadratic functions in standard form and how to graph them. A quadratic function is a function that can be written in the standard form y equals ax squared plus bx plus c, where a cannot equal 0. Because if a were to equal 0, then suddenly it wouldn't be quadratic anymore because this entire term would drop out and we would just have bx plus c, which is linear. The graph of a quadratic function is known as a parabola. P-A-R-A-B-O-L-A. It is important that we learn the vocabulary and the proper way to spell it. So for a parabola, we have a parent function. So remember that f of x is function notation is the same as saying y equals. F of x equals x squared is the parent function, meaning that is the most basic quadratic function we can have. All other quadratics are a modification of that. With a parabola, the graph of a quadratic function, we have either a maximum value or a minimum value. So if the parabola faces downward, so if we have a parabola that looks like a frowny face rather than a smiley face like this, then we're going to have a maximum value. So the maximum value is the vertex's y-coordinate if the parabola is face down. And what causes the parabola to face up or down is the a value. So if the a value, this leading coefficient, if that is a negative number, so something less than 0, then the parabola will face down like this, and so its vertex, the center point, would be the maximum value. If we have a concave up, or a smiley face looking parabola, such as we see here with the parent function, then it's a minimum value because the vertex is now the lowest point on that parabola. So it's a minimum value if it's concave up or face up. The minimum is still the vertex's y value. So it's a minimum value if a is greater than 0. So face-up parabola such as this will have a minimum at its vertex. The center point is the lowest point on the parabola. And that minimum value is the vertex's y-coordinate. Or if we change a to be a negative, flips the whole thing upside down, frowny face, and it now has a maximum value. The vertex, the center point, is now the highest point on the parabola. The axis of symmetry is an imaginary vertical line that goes straight down through the center of the parabola and divides it into mirror images. So it's a vertical line that divides the parabola into mirror images. And travels through the vertex. Because it is a vertical line, the equation is always x equals, and it's going to be x equals some number. So for our parent function, the axis of symmetry is the y-axis. It's right here at x equals 0. The vertex is the highest or lowest point on a parabola. It's the center point. The only one that doesn't have a partner pair that shares a y value. In general, we're going to refer to its coordinates as hk. So here on the parent function is the vertex at 0, 0. Here are some additional key concepts for a parabola or quadratic function in standard form. So the graph opens up, or is concave up, if the a value is greater than 0, down if the a value is less than 0. If a equals 0, it's not quadratic anymore, remember, that would make it linear. So this leading coefficient right here controls whether it faces up like this, that would be a positive a value, or if it faces down like this one, that would be a negative a value. The a value also determines whether it's a narrower or skinnier parabola, or if it's a wider, more compressed parabola. So it's narrower if the absolute value of a is greater than 1. So if this number, sitting here in front of x squared, ignoring the sign, because the sign just tells us whether it faces up or down, so if you take the absolute value of it and just look at the number, if that number is bigger than 1, it will appear skinnier, and if the number is less than 1, it would appear wider. So if the a value is 3, it's going to be skinny, or if the a value is negative 5, it'll be skinny. But if the a value is 1/2, or negative 2/3, it would be wider, because those are less than 1 when you take their absolute value. The axis of symmetry, the formula for it is x equals the opposite of b, so change the sign on the b, divided by 2a. And this is also the x-coordinate of the vertex, and that's a little formula you have to learn. That when you're in standard form, if you want the x-coordinate of the vertex, you have to take the b value, the coefficient of x, so find this number, change its sign, so if it's positive, make it negative, if it's negative, make it positive, and divide it by 2 times this a value. That'll give you the x-coordinate of the vertex, so the left to right location of the vertex, and it also tells you the equation of the axis of symmetry. Once you have that, you can just plug it into your equation to find the y value, to find out the y-coordinate of the vertex. I'm going to add one more line down here, one more important concept. So the y-intercept is 0, c. Whatever this value is here, that corresponds to your y-intercept. So let's take a look at graphing a couple of these. So here's our equation in standard form, y equals negative 3x squared. We're going to graph that, and then we're going to compare it to the parent function y equals x squared. So to graph this, we're going to fill in this table of values. So when x equals negative 2, we're going to do negative 3 times negative 2 squared. And if you choose to use a calculator for this, this is exactly how you have to type it. Negative 3, parenthesis, negative 2, close parenthesis, squared. So that your calculator knows the negative is included with the 2 in the squaring. Remember, anything squared always comes out positive. So negative 2 squared, negative 2 times negative 2 is positive 4, times the negative 3 gives us negative 12. I strongly encourage you to figure these out with mental math, or write it down on paper. Do it without a calculator. Keep in mind you will have a non-calculator portion of the test in Unit 1, and that will definitely include the graphing. So do not become reliant upon your calculator. Practice without it. If you want to check it with your calculator, that's a great idea. Just make sure you type it just like this. Okay, so do the same with negative 1, so y equals negative 3 times negative 1 squared. Again, the exponent comes first, so we square the negative 1. Negative 1 times negative 1 gives us positive 1. So it's negative 3 times 1, which is negative 3. Plug in 0, y equals negative 3 times 0 squared. Well, 0 squared is just 0, and negative 3 times 0 would be 0. Plug in 1, y equals negative 3 times 1 squared. Well, 1 squared is 1, negative 3 times 1 is negative 3. So you're starting to see the symmetry. This must be our vertex, and then we expect that 2 would also give us negative 12. So we've got negative 3 times 2 squared. We'll square the 2, you get 4. Negative 3 times 4 gives you negative 12. So here are our points. We're going to go ahead and plot them on this grid over here. So negative 2, negative 12 won't fit on our grid. That's okay, we'll graph the points that do fit. Negative 1, negative 3 right here. So left 1 and down 3. And then we'll plot 0, 0. And then we'll plot 1, negative 3, so right 1 and down 3. And again, 2, negative 12 won't fit, but that's okay. So here's the parabola y equals negative 3x squared. We're asked to compare it to the parent function y equals x squared. Well, y equals x squared would have 0, 0. If we plug in 1, 1 squared is 1. 2 squared is 4, so 2, 4. 3, 9 wouldn't fit. If I do my negatives, negative 1 squared is 1. Negative 2 squared is 4. So here's the parent function y equals x squared. And so if we're going to compare the two, what you should first notice is that our parabola is face down. So y equals negative 3x squared faces down and is skinnier, all because of that a value. So the fact that a is negative makes it face down, and then the fact that it's a 3 makes it skinnier. Alright, let's take a look at the next one. We're going to graph y equals 1/4 x squared minus 2, and then we're going to compare it with the parent function. So again, take each of your x values, plug them in, remembering to follow the order of operations. Order of operations tells us to square first. So negative 4 squared is positive 16. Then we're asked to take 16 times 1/4. Well, that's the same as saying 16 divided by 4. And 16 divided by 4 is 4. And then finally 4 minus 2 gives us 2. If we plug in negative 2, we've got 1/4 times negative 2 squared minus 2. Well, negative 2 squared is 4. 4 divided by 4 is 1. And 1 minus 2 gives us negative 1. If we plug in 0, 0 squared is 0. Divided by 4 is 0. Minus 2 gives us negative 2. Plug in positive 2. Well, 2 squared is 4. 1/4 times 4, or 4 divided by 4 is 1. Minus 2 gives us negative 1. So we're starting to see the symmetry. This must be our vertex, and then we'll build symmetry outward, meaning we expect to get 2 when we plug in 4. Well, 2 squared is 4. 4 divided by 4. Oh, I'm sorry, I was plugging in 2 again. I should be plugging in 4. So 4 squared is 16. 16 divided by 4 is 4. 4 minus 2 gives us 2. So we can go ahead and plot these points. Negative 4, 2. So left 4 and up 2. Negative 2, negative 1. Left 2, down 1. 0, negative 2 means don't go left or right, just go down 2. 2, negative 1 means to the right 2 and down 1. 4, 2 means to the right 4 and up 2. Here's my parabola. And again, I'm going to compare it to the parent function. So the parent function is 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. And so what we see is our graph. So y equals 1/4 x squared minus 2 is wider because a equals 1/4, which is less than 1. So when a is a value less than 1, it makes the graph wider. And then the vertex has moved as well. So the vertex moved down because of that c value. So because c equaled -2, it moved the graph downward and changed our vertex from 0, 0 to 0, -2. You've probably heard me use the term concave throughout this presentation so far. Concavity just refers to whether the parabola faces up or down. It will be concave up, like a smiley face, if a is greater than 0, and concave down, like a frowny face, if a is less than 0. Okay, let's take a look at another example. So in this example, our standard form equation is y equals 2x squared plus 6x plus 3. So we have an a, b, and a c value. So that's the first thing we're going to do, is identify those coefficients. So a is the coefficient of x squared, which in this case is 2. B is the coefficient of x, and c is your constant, the number that's just a number. That's 3. Concavity is determined by the a value. If a is positive, it's face up. In this case, it is. It's face up since a equals 2, which is greater than 0. It will also be skinnier because 2 is bigger than 1. The absolute value of a is 2, which is bigger than 1, so it will be a skinnier parabola than the parent graph. So to find the vertex, we're going to use that little cheat formula that we talked about in the important concepts box, that the x-coordinate of the vertex, or the axis of symmetry, is equal to the opposite of b divided by 2a. And again, that's a formula you need to memorize. You have to know it. It is actually the first part of the quadratic formula. If you remember the quadratic formula, it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So this first fraction is the x-coordinate of the vertex, the opposite of b over 2a. Okay, so let's go ahead and plug in. B was 6, so the opposite of 6 is -6. A is 2. So we get -6 divided by 4. Doesn't divide evenly, but we can reduce them both by 2. So if we divide -6 by 2, we get -3. 4 by 2, we get 2. So the x-coordinate of the vertex is -3/2, or -1.5. So I'm going to go ahead and dash in my axis of symmetry at x equals -3/2. Okay, so now to find the y-coordinate of the vertex, I need to plug that in. So it's 2 times -3/2 squared plus 6 times -3/2 plus 3. Well, -3/2 squared, -3 times -3 is 9. 2 times 2 is 4, so it's 9 over 4. And then I'm going to remind myself that when I take a whole number times a fraction, the whole number is always over 1. So the whole number is only multiplied by the numerator, the denominator is unaffected. So I'll get 18 over 4 minus 18 over 2 plus 3. Both fractions can be reduced, but I'm only going to reduce the first one by 2 and turn it into 9/2 so that I have a common denominator with the next one. And then I'm going to turn 3, which is 3 over 1, into 6 over 2. I'm going to multiply top and bottom by 2. 3 times 2 is 6, 1 times 2 is 2, just so that I have a common denominator for all 3 values so that I can combine these and add them all up to find a total. So 9/2 minus 18/2 would be -9/2, because 9 minus 18 is -9. And then -9/2 plus 6/2 is -3/2. And I do strongly encourage you to begin working in terms of fractions rather than decimals. You will find it's much more efficient, and you keep the exact value. Alright, so here's our vertex at -1.5, -1.5. So that's right here. We need some more points to plot to graph this parabola. So reminder that the y-intercept is the c value. So 0, 3 is a point on the parabola, because if we replace x with 0, 0 squared is 0, times 2 is 0, plus 6 times 0, which is 0, so 0 plus 3 gives us 3. So we'll go ahead and plot 0, 3. That's 1.5 units to the right of the vertex, so if we go 1.5 units to the left of the vertex, we would find the mirror image of that point. I'm starting to see a basic shape of the parabola. We want to do one more set of points just to get a really accurate shape. So choose something close to your vertex so that you're sure it will fit on your graph. So I'm going to choose x equals -1 for my additional x value. So I plug -1 into my equation, keeping in mind the order of operations. So order of operations tells me first I have to square the -1. That'll give me +1. Then I do my multiplying. So I'll have 2 minus 6 plus 3. And now I add and subtract from left to right. 2 minus 6 is -4. Plus 3 gives me -1. So another point on the graph is -1, -1. When I replaced x with -1 in the equation, the output was -1. That's half a unit to the right of the vertex, so if I go half a unit to the left of the vertex, I'll get its mirror image point. And I'm getting now a good sense of the shape of the parabola, and I can sketch it in. So that's the process in general. You identify A, B, and C. The A value tells you whether it faces up, if it's positive, or down if it's negative, and whether it's skinnier or wider. So if the absolute value is greater than 1, it's skinnier, less than 1, wider. We calculate the vertex. If you're in standard form like this, to find the vertex, the x-coordinate is always the opposite of the b value divided by 2 times the a value. So in our case, b was -6. B was 6, and so we do the opposite of it, -6, divided by 2 times the a value, which was 2. So we got -6/4, which reduced to -3/2. Plug it into your original equation in place of all your x's. Follow the order of operations and solve to find the y-coordinate so that you have the coordinates of your vertex to plot. The axis of symmetry always is the vertical line straight through that vertex, so whatever you get here for the x-coordinate, that's your axis of symmetry. And then you can always mirror points on either side of it. So if we find the y-intercept, you can mirror it on the other side. And then it's always a good idea to find one additional point, so choose an x value really close to your vertex, plug it in to find y, and then mirror it on the other side. Okay, so the last type of problem we're going to see in this section is how to determine if a quadratic function has a minimum or a maximum value. So first of all, the minimum or maximum will be determined by the concavity. If it's face up, you're going to have a minimum, like we see here. The vertex is the lowest point on the parabola. It's unbounded at the top, so it doesn't have a maximum. If, however, the parabola is concave down, it's going to have a maximum because the vertex would then be the highest point. And that's exactly what's going to happen here. Because a equals -1/4, which is less than 0, it's concave down, which means we will have a maximum value because the parabola will look something like this, and so the vertex is the highest point. To find it, we use our little formula, x equals the opposite of b over 2a. So remember that a was -1/4, b was -7, and c was 2. So the opposite of b, well, b is -7, so the opposite of that is +7. 2 times the a value of -1/4. Okay, remember 2 is 2 over 1, so 2 times -1/4 will be -2/4, which reduces to -1/2. Friendly reminder that division by fractions is undefined. We never divide by fractions. Instead, we multiply by the reciprocal. So the reciprocal of -1/2 is -2 over 1, or -2, which means our x-coordinate of our vertex is -14, because they're asking us to find the maximum value. Well, the maximum value is going to be the y-coordinate of the vertex, but I need this x value to know what to plug in to find the y-coordinate. So now that I have it, I plug it into the equation. So -1/4 times -14 squared minus 7 times -14 plus 2. Well, -14 squared gives you 196. So you have -1/4 times 196. -7 times -14 is going to give you +98. 196 times -1/4 is the same as 196 divided by -4, which is -49. plus 98 plus 2. Well, negative 49 plus 98 is 49. Plus 2 gives us 51. So, as our conclusion to this problem, we can say maximum value of 51 when x equals negative 14. So the largest value we're going to get out of this function is 51, and it occurs with an x value of negative 14. Okay, so that's everything we're going to look at in this section on standard form. The next thing you're going to do is just a little graph and calculator activity to learn some more about how to use the calculator and how it can actually find the coordinates of the vertex for you, so it can find the maximum or minimum. You'll need to open your textbook to page 10. You'll need your graph and calculator, and then you're going to record your answers right below this in your notes packet.